Hello, my name is Mario Markov, and today I'll present to you our work on FireScope, Wildfire Risk Raster Prediction with a Chain of Thought Oracle. You can see the results of our work in our website, firescope.ai, and you can find our dataset and our code in our project page in GitHub, linked here. Wildfires are a serious issue, causing millions in damages worldwide. Here you can see a bar plot of the area burned by wildfires in the United States per year provided by the National Interagency Fire Center. As you can see, there is an increasing trend. However, wildfire detection is not the same as wildfire risk estimation. While wildfire detection is tasked with finding existing wildfires, wildfire risk estimation is a complex multimodal reasoning problem integrating many factors, not simply visual cues, such as climate, topography, and it's tasked with predicting a continuous risk field across an area where each pixel is assigned a value quantifying the combination between the probability of a wildfire occurring there and the expected intensity of a wildfire should one occur there. Currently, there is no unified benchmark for this task, and it remains largely unexplored within the field. Thus, we introduce a large-scale dataset and benchmark called FireScope-Bench, which combines satellite images from Sentinel-2, continuous wildfire risk rasters in the United States from the Wildfire Risk to Communities project by the USDA Forest Service, real wildfire events in Europe from the EFIS Burnt Areas collection, in addition to control areas, as well as climate data from the NASA Power API. FireScope-Bench enables training models on wildfire risk rasters in the US and then evaluating their generalization in cross-continental settings on real wildfire events in Europe. We then propose a framework that we call the FireScope framework, which combines the reasoning capabilities of a large vision language models with a dense vision encoder-decoder. What we call a chain of thought oracle is trained with group relative policy optimization to reason about the area and all its various multimodal factors and produce a final risk score for the area, quantifying the overall risk generalized across the entire area. This integer is then fed to a vision encoder-decoder, which, given also the satellite image, produces the fine-grained dense risk raster. When training the chain of thought oracle, we only supervise its final answer, thus allowing its reasoning to evolve naturally for the task at hand, whereas the encoder-decoder is trained with supervised training with a differentiable loss. A big part of our work is the result that chain of thought reasoning enables more robust generalization, and to ablate this, we perform our experiments on 4 configurations in total. First, we train the encoder-decoder without any conditioning, giving it the image only. We train it giving it the raw climate vector. We train it with an oracle which does not perform chain of thought reasoning, and we train it with the chain of thought oracle. And as you can see in our results here, in the left table, which quantifies in-distribution performance, the chain of thought oracle remains robust. However, on the right table, which quantifies out-of-distribution performance compared to in-distribution performance, the chain of thought oracle leads to far superior performance out of distribution. This suggests that chain of thought enables the model to ground its predictions on more generalizable features and correct spurious correlation. Further, the chain of thought oracle leads even to improvement in the fine-grained predictions. As you can see on the right side in this table, the chain of thought oracle improves even the performance on individual wildfire pixels within the images of wildfire events, suggesting that the encoder-decoder uses the chain of thought oracle not just as a post-processing step, but as a contextual prior, helping it focus its attention on what's important. To see more of our results, in addition to studies of the model's interpretability, with metrics and with Wildfire experts, please refer to our paper. Thank you.